Good morning students, my name is Priyanka Jain. In previous session we have completed some cases of Gauss theorem. Now we have applications of Gauss theorem. Our first application is electric field intensity due to a point charge. Now we have considered a closed surface whose center is O, radius R and a small area that is ds, intensity and charge plus q. Okay, so now by electric flux we know that in a closed surface, electric surface or electric field intensity will be equals to ds cos theta. Now we will have to see the cos theta with respect to ds and the intensity. So angle theta is an angle between intensity and ds, that is surface. Now we have seen the angle between intensity E and ds will be 0 degree, so theta will be 0 degree and cos theta is equals to cos 0 degree will be 1. So now we get E is equals to ds into 1. So ds and by integrating we get in a closed electric flux is equals to E into ds, that is our equation number 1. Now this is our total closed surface area. So phi ds, that is closed area surface, is equals to pi r square. Now from equation 1 and 2, this is our equation number 2, we get phi E is equals to E into, here is the phi ds is equals to 4 pi r square, then 4 pi r square, that is our equation number 3rd. Now by Gauss theorem phi E is equals to 1 upon epsilon 0 into q, that is 4th. Now by this and this we get 1 upon, or by equation 3 and 4 we have E into 4 pi r square is equals to 1 upon epsilon into q, then E is equals to 1 upon epsilon 0 into q upon 4 pi r square. This is our intensity, electric field intensity due to a point charge. Okay, T due to a point charge. Now we have taken electric flux is equals to phi into E into ds cos theta. This is our equation number 1. Now we have taken theta, that is angle between intensity E and ds. So angle will be 0 degree. So the cos theta will be cos 0 degree, that is cos 0 degree will be 1. Now phi E is equals to surface E into cos 0 degree will be 1. So ds into 1. Now phi E is equals to enclosed surface E into ds. This we got. Now if we take E outside and this phi here, then we got E into phi ds, and this phi ds is known as the total surface area. So we got phi ds is equals to 4 pi r square. Now 4 pi r square we got for value of phi ds. Now this is our equation number 1 and this is our equation number 2. From equation 1 and 2 we got phi E is equals to E into 4 pi r square. Because phi ds is equals to 4 pi r square, now we got our equation number 3rd, that is E into 4 pi r square. Now by Gauss theorem we know that phi E is equals to 1 upon epsilon into q. This is our Gauss's theorem. By equation 3rd and 4th we got phi E and phi E, this left hand side is equal, then right hand side will be equal. So we got E into 4 pi r square is equals to 1 upon epsilon into q. Now E will remain this side and we got E is equals to 1 upon epsilon into q upon 4 pi r square. This is our intensity due to a point charge. Now our next application. Now our second application is derivation of Coulomb's inverse law. Now we have taken a closed surface where O is the center with present Q charge, radius R, intensity E, P where small q charge is present, and area is ds. Now we know that electric flux passing through an area will be equals to phi E into ds cos theta. Again we have to take angle between intensity E and ds, that is very small surface area. So theta will be 0 degree. Cos 0 degree is equals to 1. Now phi E is equals to phi E into ds cos 0 degrees, that is 1. We got phi E is equals to phi or surface area into E into ds. Now we have taken closed surface here and ds here and E is front. Now we got phi E is equals to E into phi s ds, that is the closed surface area or the total surface area, and total surface of sphere is equals to 4 pi r square. Now from equation 2 we get phi E is equals to E into 4 pi r square, because phi ds is equals to 4 pi r square. Now by Gauss theorem phi E is equals to 1 upon E into q, that is equation number 4th. From equation 3rd and 4th, from equation 3rd and 4th we get E into 4 pi r square is equals to q upon epsilon 0. Now E is equals to 1 upon 4 pi r square into q upon epsilon 0, that is our 5th equation. Now by definition of electric field intensity, E is equals to F upon, now E is equals to F upon Q and F is equals to Q into E. Then from equation 5th we have this value of E. We put this value here. F is equals to 1 upon 4 pi epsilon 0 into Q upon R square. That is the Coulomb's inverse square law. We have proved this law by Gauss theorem. Now we will see our next application, application number 3rd. Our third application is electric. In this we have 3 cases. When the point P is outside the sphere, here we point P. Now if point P lies outside the surface, when the point P lies on the surface, and when P lies inside the surface. So we will see these three cases now. Now our first case is when the point P lies outside the sphere. Now here is the distance is x, then the radius of this sphere will be equals to x, and the radius of this r will be greater than x, because this is our small surface area, that is ds. Now thus the electric flux linked with Gaussian surface, then this will be equal to, now phi E is equals to phi E into ds cos theta. In previous we have seen that phi is equals to E into ds, that is the total surface area of a sphere, that is 4 pi r square. Now we have written E into 4 pi r square. Now by Gauss theorem we have phi E is equals to q upon epsilon 0, and from here we can see that r is equals to x, so we can put here r is equals to x, E into 4 pi x square is equals to q in upon epsilon 0. E is equals to 1 upon 4 pi epsilon 0 into q upon x square. This is our required formula for the when the point lies outside the sphere. R will be equals to x, then this intensity of electric field will be equals to 1 upon 4 pi epsilon 0 into q upon r square when point lies on the surface. Okay, when point lies on the surface, our case number 2, then r will be equals to x, then E is equals to 1 upon 4 pi epsilon 0 into q upon r square. Now our third case is when point P lies inside the sphere. Sphere at distance x from the center, where we are to find the intensity of electric field, but there is no charge within the Gaussian surface. Hence Gauss theorem phi will be equals to 0. Hence E will be equals to 4 pi r square into 0. E is equals to 0. Thus the intensity of electric field at each point inside a uniformly charged conducting sphere is 0. Now rest of the part we will continue in next session. Thank you and have a nice day.